Set which does not contain any element is called as empty set. As the name says, the set contains only one element or single element is called as singleton set. So when I say x less than 5, obviously the number should be x less than 7. There is no number which can be less than 5 and greater than 7. We have one element inside the set. So therefore this is an example for finite set. Hello everyone, a warm welcome to one and all. This is your Shruti ma'am lecturing in Vidhyaashram, the Temple of Excellence, Mysuru. So we are in session 2 of the chapter sets. In our previous session, we have learnt what is set and how to represent a set in two different forms, that is roster form as well as set builder form. In this session, we are going to study about the types of sets. So how many types of sets, their definition, examples. Now let's see the first one, empty set or null set or void set. As the name says here, empty. That means there is no elements inside the set. So set which does not contain any element is called as empty set. The empty set is always denoted using the symbol phi. So this is called as symbol phi, or we can just keep it as an empty braces. So never ever write it like this. So this is wrong. Either you should write an empty set using the symbol phi or like empty braces. So that denotes there is no element inside the set. So example is here, set A I have taken here. I need to take x between 5 and 6, but x should be a natural number. Clearly we know that natural number is a set where we have 1, 2, 3, 4, 5, 6, etc. like this. There is no natural number between 5 and 6. So therefore this set will be empty set. That is no elements inside the set. This is an example for set. Next one, the set of odd natural number divisible by 2. None of the odd natural number is divisible by 2. So therefore, set B is an example for empty set. That means there is no natural number which is exactly divisible by 2. So therefore, there is no element inside the set B. Hence, this is an example for empty set. The next one is singleton set. As the name says, the set contains only one element or single element is called as singleton set. So therefore, example is here, the set of even prime numbers. We know there is only one even prime number, that is 2. Hence, if I write it in the form of a set, I'll get it like this. So we have only one element 2 as an even prime number, which is an example for a singleton set. Next one is x belongs to a natural number and x square is equal to 25. When I say x square is equal to 25, there is only one natural number 5 whose square is equal to 25. So therefore, we have set B is equal to 5 as an element inside the set. Therefore, that is also an example for singleton set. Next. Which of the following are examples for the null set? So, the set will be either given in the roster form or by the set builder form. However they have given, you need to identify the elements and verify it whether it is a null set or not. Set of odd natural number divisible by 2. None of the odd natural number is divisible by 2. So, therefore, this is an example for null set. So, the first one is null set. Set of even prime number. When I say set of even prime numbers, we have an element inside the set, that is 2. So we have an element, therefore it is not a null set. So this is not null set. Next question we have, x is a natural number, x less than 5 and x greater than 7. So when I say x less than 5, obviously the number should be x less than 7. There is no number which can be less than 5 and greater than 7. So therefore, it is an empty set. So therefore, this is an example for null set. Next, y is a point common to any two parallel lines. We know that two parallel lines never intersect each other. If we say an intersecting line, there should be a common point of intersection. But parallel lines do not intersect each other, therefore they do not have any common points. Hence, this is also an example for null set. Therefore, a set of point common to any two parallel line is a null set. Next, we have finite and infinite set. So, a set which is empty, an empty set can also be considered as a finite set, because we can easily say there is no element inside the set. And a set which contains definite number of elements, where I can write the number of elements inside the set. For example, set of vowels in English alphabets, then how many elements are there? 5. When I say colors of a rainbow, we can write there are 7 elements inside the set. So therefore, when I can define the number of elements in the set, it is an example for finite set. If I can't define the number of elements, or if it is infinite number of elements, we say the set is infinite set. For example, set of natural number is an example for infinite set, because we can't write the elements until the last number, which is infinite. So therefore, we call this is an example for infinite set. When I say, let me denote D, days of a week. So therefore, this is an example for finite set. We have 7 elements here. We can't write how many number of elements here. So therefore, this is an example for finite, and this is an example for infinite set. Next, examples are given here. W be the set of days of the week, therefore W is a finite set. G be the set of points on a line. We know a line is a collection of points, but we doesn't know how many points are connected to form a line. So therefore, the points are infinite to form a line. So therefore, this is an example for infinite set. Let B be the set of months in a year. We have 12 months, hence it is a finite set. P be the set of prime numbers. Prime numbers are infinite. We can't write what is the largest prime number. So that is, it goes until infinity. Hence, P is an example for infinite set. Now, here are a few examples. We need to identify which of the following are finite and infinite. First one, x belongs to 1 and x minus 1 comma x minus 2 is equal to 0. We have an equation which clearly says x can take the value 1, x can take the value 2. So therefore, the only elements of this set is 1 and 2. So clearly we can say it is an example for finite set. Next we have x belongs to natural number whose square is equal to 4. So we have only one number 2 whose square can be equal to 4. So therefore, the element of this set is 2. We have one element inside the set. So therefore, this is an example for finite set. Next, x belongs to n and 2x minus 1 is equal to 0. X should be a natural number. When I say 2x minus 1 is equal to 0, x takes a value of 1 by 2. But 1 by 2 is not a natural number. So therefore, there is no element inside the set. We know that empty set is also finite. So therefore, this is an example for finite set. Next, we have x belongs to natural number and x is a prime number. The natural prime numbers are 2, 3, 5, 7, 11, 13, 17 and it goes on. So therefore, this is an example for infinite set. Next, x belongs to natural and x is odd. Odd natural numbers, when I say 1, 3, 5, 7, 9, 11, 13, 15 and it goes on. So therefore, this is an example for infinite set. Next, we'll take few more examples. State which of the following sets are finite or infinite. The set of prime numbers less than 99. When I say in less than 99, it is understood we have a very finite number of elements. So therefore, this is a finite set. The set of positive integers greater than 100. Greater than 100 means it can extend to until infinity. So therefore, this is an example for infinite set. The set of lines which are parallel to x-axis. We have infinite number of lines which is parallel to x-axis. You can remember your coordinate system, x and y-axis. Many lines are parallel to x-axis as well as y-axis. So therefore, this is an example for infinite set. The set of numbers which are multiples of 5, we have n number of multiples of 5 or infinite number of multiples of 5. So therefore, this is an example for infinite set. The set of circle passing through the origin 0, 0. So when I say origin 0, 0, many circles can pass from here. So infinite number of circles can pass. So therefore, this is an example for infinite set. So next one is equal sets. So when I say equal sets, here we are comparing two sets. How we are going to compare? Let's see. Two sets A and B are said to be equal if they have the exactly same elements. When we denote it by A is equal to B here. So here, when we say A is equal to B, A and B should contain exactly the same elements, however may be the order. Suppose set A has 1, 2, 3, set B has 3, 2, 1, they are equal because they contain same elements 1, 2, 3, 1, 2, 3. Order doesn't matter here, otherwise we just call it as unequal sets. So we have taken an example here. Set A is equal to 1, 2, 3, 4. Set B is equal to 3, 1, 4, 2. All the elements in set A is in set B. All the elements in set B is in set A. So therefore, we'll write it as A equals to B. Now, when I say set C is equal to 1, 2, 3, 4, set D is equal to 1, 2, 3, 5. Here, 1, 2, 3, 4 is not there in D. And when I say 1, 2, 3, 5 is not there in C. So, 1, 2, 3, 4, when I say in C, it should be in D. So, therefore, we have an element which is not in D here. So, we write C not equal to D here. So, it may be finite or infinite set, but A and B must have exactly the same elements. Now, here is an example given. From the sets given below, select equal sets. We need to select what are the equal sets here. So, compare each and every set with other sets. So, clearly you can see here, we have set A 2, 4, 8, 12, B 1, 2, 3, 4, C 4, 8, 12, 14, D 3, 1, 4, 2, E minus 1, 1, F 0, A, G 1, minus 1, H 0, 1. Clearly you can see set B is equal to set D here because they contains the number 1, 2, 3, 4. And set E is equal to set G because both have 1 and minus 1. Other than that, there are no equal sets. Next, find the pairs of equal sets if any, give reason. Set A is given, we have an element 0. Set B is given, we need to find an element X which is greater than 15 and less than 5. Clearly, there is no element like that. So, therefore, this is an empty set. C is X minus 5 is equal to 0. I can write 5 as an element inside the set. X square is equal to 25 means we have two numbers whose square can be 25. One is minus 5, another one is plus 5, whose square can be 25. But when any natural number is represented, we can choose only 5 because only 5 is a natural number here. Next, X is an integral positive root of the equation x square minus 2x minus 15 is equal to 0. So, let us solve x square minus 2x minus 15 is equal to 0. Clearly, they have mentioned you should choose only integral positive root of the equation. So, even though the solution may be negative or positive, we need to choose only the positive values. So, clearly here we can see x minus 5 and x plus 3 or the roots of the equation. So, therefore, the solution for this set E is, we need to choose only the positive root. So, therefore, 5 we can choose because when I say x plus 3 is equal to 0, x is equal to minus 3 which is not the positive root. So, therefore, E has 5. Now, see here how many pairs of equal sets are there. We can see C and E are equal here because they contains the same element 5 and 5. So, clearly we can write here C is equal to E. Next we have which of the following pairs of sets are equal? Justify your answer. So, we need to see the set given here. Set X is a collection of alike. So, therefore we can write A, comma, L, comma, O, comma, Y. And set B is the letters of the word loyal. So B is L, comma, O, comma, Y, comma, A. So clearly see we have the letter A, L, O, Y in B also. So therefore clearly we can say X equal to B. So next we will observe the second one. We have N belongs to Z, N square less than 4. We need to choose an element N whose square is less than 4. Hence we can take -2, -1, 0, 1 and 2. We can't take -3 and +3 as an integer because their square is 9, which is not less than 4 here. Next we have B, which is a solution of the equation x square minus 3x plus 2 is equal to 0. So we can have the solution here 1 and 2 here. For this equation, x square minus 3x plus 2 is equal to 0 can be split it into linear factors as x minus 2 and x minus 1. Hence, the solution can be 1 and 2. Clearly, you see the element differs here. So, therefore, we can write here A is not equal to B. Next question. Are the following pairs of sets equal? Give reason. So here one pair is given. We need to find whether they are equal or not. Set A is given as 2, 3. Set B we need to find out. Clearly this one can be written as x plus 3, x plus 2 is equal to 0. Hence solution of B can have, if I say x plus 3 is equal to 0, then the value of x is minus 3 and minus 2. So clearly here A has 2 and 3, B has minus 3 and 2, which are not equal. So, therefore, they are not equal. The next pair is given as X is a letter in the word follow. So, F, O, L, W. So, this is the set A. Next is wolf. Set B is W, O, L, F. They have exactly the same letters inside the set. So, therefore, we can say A is equal to B. So thus, this is all about the equal sets. We will take few more types of sets in our next session. Until then, keep watching, keep learning, keep exploring. Thank you.